Excited to talk to you tonight about cloud infrastructure in Go with Pulumi. So things we're going to be covering today. First, provisioning. And this is, treating our infrastructure as cattle, not pets. We want to be able to manage this stuff in mass. We don't want to give things names. We want to spin it up. We want to spin it down. We want every developer to be able to have their own stack. We want to be able to experiment. Second, we're going to cover architecture, using things that we would traditionally use in software design, abstraction, encapsulation, sharing these best practices across teams, creating architectural components. And the last thing we're going to cover is testing. So this is unit and integration tests that give you confidence to move quickly, deploy software often, give you the confidence to hit that green button and not have to babysit your deployments. So prerequisites, some of this material was sent out ahead of time, but if you're still curious and want to follow along and you haven't done this yet, I'll leave this up here for a second. You can walk through pulumi.com/doc/getting started. This will help you download the Pulumi CLI and get set up with the AWS CLI. We have installation instructions for Mac, Linux, Windows, etc. Then all of the content that will be covering tonight is from the Pulumi examples repo. So if you want to clone this repo into your Go path, you can follow along, run the examples as we go. And there will be live demos at almost every step. So I'll leave this here for just a moment in case anyone wants to enter those URLs in their browser real quick. And also if you Google Pulumi getting started or if you just search for Pulumi examples GitHub, you will find this content on there. So you want to go to the cloud. Go to the cloud. Well, how do you get there? There's an awful lot of choices and it's fairly confusing. You could start by creating a VM in 7 easy steps in the AWS console, or use the AWS CLI, or the SDK, or CloudFormation, or Terraform, or Chef, or Puppet, or Ansible, or wow, that hurts, right? There's an abundance of choice. So let's just slow down for a minute and take a step back. What do we want out of our cloud development process? DevOps Wild West, yes. So what do we want out of our cloud development process? We want maintainable, correct systems first and foremost. A tooling process that works for the whole teams. Like software doesn't exist in isolation, right? We have to be able to, work with others. We want confidence making changes. We don't want to babysit our deployments, and we want to be able to iterate. Don't want to have to spend lots of time constructing a developer environment that needs to be babysat and upgraded and patched. And, are these goals really any different from traditional software development? I don't think so. So, why not use the same development toolchain that we're using elsewhere? Same tools that we love, that good old Gopher. So let's start out with a demo. I want to create a simple web server. So that's going to involve creating a security group with public ingress on port 80, then looking up the latest Amazon Linux AMI, create an EC2 instance using those two values, and we're just going to specify to start a simple launch script that sets up a server on port 80 and export that public DNS. So here, this is the part where you can grab your computer. So I am right now going to CD into my Go path, and if you want to follow along here, what you can do is make dir-p $GoPath/src /Pulumi/ yep, and then we're gonna CD into that same location. And then we're going to clone into the Pulumi examples repo. And so we're going to CD into examples. You can see we have an abundance of examples here that you can play around with later, everything from F# examples in Azure to TypeScript on GCP, Kubernetes in whatever language you can desire. But today we're going to be focusing primarily on AWS. So we're going to CD into AWS Go web server. I'll launch that, that code here so that we can take a look at it. Take a look there in a minute. And so I'm going to go ahead and start off by getting a new stack created. So I'm going to Pulumi stack init. So I'm going to create a stack called DC Go. All right, and now I'm going to set up a little bit of configuration. We need to tell Pulumi what AWS region do we want to deploy to. So Pulumi config set.
The screen isn't on your terminal right now.
Oh no, okay. Okay, so sorry about that. I will walk through what those steps were real quick again, just for those who missed it. I'm going to put a set of slides up in case you missed it. So what we did here was just make dir-p, go path source github Pulumi, cd into that directory, and then git clone github.com Pulumi examples. Okay, and so now we're cd'd into, if I just do a pwd here, we're cd'd into go path source github Pulumi examples AWS Go web server, and I ran this command Pulumi stack init. This is going to create a new ephemeral developer environment for me to deploy into and organize my resources with. I went ahead and set the AWS config. So let me do that real quick. Pulumi config set AWS region, and I'm in US West 2 because I'm on the West Coast. So that's where I want to deploy my EC2 instances into. And then from there, I can do Pulumi up. And while that's going, I'm going to go ahead and switch over to the presentation. And here are these steps here so that you can follow along yourself if you want to. And I know we haven't looked at any of the code yet. We know where we're going. We're deploying a web server, and we're using this command line tool called Pulumi, but we don't really know much more than that yet. While folks are getting this set up for themselves, I'm happy to answer a few questions here in the meantime. This doesn't assume that you already have Pulumi installed. Yep. If you have not done that, feel free to just follow along the slides. I'm going to go through all the code, and we'll see the results of everything that's being deployed. Or you can go to the Getting Started link that I mentioned in the first line. If you search for Pulumi Getting Started, that walks you through getting this set up. Yep, I will walk through the code. Okay, so why don't I go ahead and get started doing that. So let's break it down. What do we have here? So this is our shell. Just to show y'all what the code looks like in its entirety. You know, it's about 50 lines here, but I'm going to break it down piece by piece for you. So we start off with just a simple import to the Pulumi core engine Go bindings, and these just define a set of types, some convenience functions, a context object that is very similar to the context object you might use in your normal Go programs. And we have here this Pulumi.run function, which gives us a context in which to create cloud resources, attach cloud resources, etc. So inside of there, we're now going to start actually creating cloud resources. So we've imported a set of bindings to the AWS SDK here, the Pulumi AWS SDK, and we're creating a new security group. And you can see this security group defines simple ingress over TCP from port 80 to port 80 and defines a CIDR block. Spend just another second here in case anyone wants to read through this. Looks fairly similar to other Go code you might see. The Pulumi.string and Pulumi.int may look a little strange, but we'll get to that in just a couple of slides. From there, we're going to go and look up the AMI. So we have a utility to do this where we can use this, this pattern expression here, hvm-star, to look up the most recent Amazon Linux AMI. From there, we're going to use that AMI and that security group ID here to create a EC2 instance. And our web server is fairly low tech. It's just a bash script. It's going to echo hello world into an index.html file. And then we're going to run Python in the background. We're just going to run a simple HTTP server on port 80, which we've already exposed through the internet through our ingress. So let's go back to our window here and see what happened. Well, we previewed our update. It showed us that we created this new stack, this container for our resources. We created our security group and our EC2 instance. Great, and it looks like we also exported some resources here. So let's go back and look at that. Context.export, public IP, and hostname. So we can take these results off of the server that we created and export them, which gives access to tooling either through the command line. Other Pulumi programs can now reference and import these values. This allows you to break up your infrastructure into manageable chunks so that when you do a deployment, you don't necessarily have to worry about updating, hundreds of pieces of infrastructure. So if we go ahead and do a curl on this, we see hello world, great. And the other thing that's really cool about this is we can actually do subcommands to Pulumi. So Pulumi has a Pulumi stack output command. We can say, what was the name of that? That was our public host name. So if we do a subcommand here, that still works. Pulumi goes and retrieves the value, and curl reads that in and hits the server. So yeah, stack outputs are great because they're highly composable, highly toolable, allows you to create automation, DevOps tooling, things like that. So let's go ahead and stop here for some questions. I saw one question right off the bat, which was, is Pulumi like Heroku? And the answer to that is no. Pulumi is not a PaaS. Pulumi is a set of libraries and an engine and a CLI that allows you to interact with like any cloud. So you can deploy resources to, we have all the resources of Azure, AWS, GCP, modeled, vSphere from VMware, lots of other things like that. So Pulumi is a SDK for building and defining your cloud applications in any cloud. How is state managed? So there's two options here. So state is either managed in the Pulumi SaaS. So we have a free SaaS backend. It's free to individuals, free to open source community for anyone to use. And there's obviously like paid plans if you have like a larger enterprise or something like that. But we also have open source backends for you to store your state either locally, just on disk, or you can store your state S3, Google Cloud Storage, Azure Storage. So we have pluggable backends that you can use for different cloud storage. But by default, it is managed in our SaaS. What makes Pulumi different? Well, we're actually going to go through that. So what makes Pulumi different from what? So why might you just not use the AWS SDK? Well, that's a very good question. I'm going to defer that for just a moment, right? So here's a pop quiz for everyone. And what I want to know is Pulumi, based on what you've seen, is it imperative or is it a declarative desired state configuration? Trick question, hey. All right, yeah, why not both? Yep, anyways, the answer is both. So let's go ahead and take a look at this real quick. We're gonna do a Pulumi stack export. Okay, and so this is gonna go ahead and grab that desired state configuration that we were looking at. So let's see what we can find here. So this is an EC2 instance. It's our web server www. And so you can see this is a type AWS EC2 instance. We have our inputs here. And so this is what was used to create. And we allowed some defaults to get specified here. Here's the AMI that we wound up looking at that got resolved at runtime. Here's that user data that we specified. And we also have some outputs and things that were created by AWS and then returned to us. Awesome. So what does that mean? We write imperative code. Pulumi executes it, produces a declarative desired state file, and then drives to that desired state. Any questions? All right. So ephemeral environments. Pulumi creates reproducible, isolated instances of your projects. We call these stacks. So Each developer can spin up and tear down environments at will. You can create stacks in multiple cloud accounts. You can have stacks in your production account, and you can have your development in a separate account that's completely isolated. And this allows you to treat your resources like cattle, not pets. You can spin them up and down as you please. If your stack becomes borked, you can just blow it away and create a new one. So the workflow for this looks something like Pulumi snack init, which is where we create an isolated environment. Pulumi up is where we deploy to it. And Pulumi destroy is where we clean up all of those cloud resources so that we don't continue to get charged for them when we're not using it. Then if you want to remove that stack and delete all of the history associated with it, all of the config, Pulumi stack RM. So I'm going to actually go ahead and do that real quick because I don't want to keep getting charged for those resources. So I encourage anyone else who may be following along at home, Pulumi destroy -- yes, and this will get your resources torn down. Okay. Any questions? Is it possible to use multi-cloud for a stack? Yes, you can create stacks that deploy to multiple clouds. Absolutely. You can even create stacks that deploy to multiple different AWS accounts. We have this notion of something called a provider. So if you want to create a provider that goes into separate AWS accounts, you can do that and configure them with different credentials. And then when you create a resource with a given provider explicitly, it gets placed inside of that account. How feature complete is this compared with cloud-specific solutions? Extremely feature complete. So the Pulumi providers actually are currently based off of the Terraform providers. So that means that with there's communities of thousands of developers contributing and using these things across the globe. So oftentimes within days, if not hours, of features being announced, there's support in the providers. So some of the providers we've actually built ourselves, like we use the Open API spec for Kubernetes. And so this past week when 0.18 came out for Kubernetes, we actually had our update released before Kubernetes had their branch cut, which was pretty cool because the whole provider is code generated. What is my take on the AWS CDK? How do you think this will impact Pulumi development from official supported frameworks? Yeah, so I think CDK is a great tool. One thing that we're seeing with our largest customers and a lot of our customers is that these days, companies are not just taking advantage of one cloud. It's not necessarily that in one stack they're deploying to multiple clouds, but they want to be able to take advantage of the machine learning assets in GCP, or they don't want to be tied in on price. We have a lot of Kubernetes workloads where people want to be able to lift and shift to clouds and don't want to be locked into a particular vendor. CDK is a great tool, but you use CDK for your AWS development, and then what are you going to use for your Azure development? What are you going to use for your GCP development? So, anyways, Pulumi is great because it gives you and your teammates a consistent programming model. It allows you to use the tools you're familiar with across clouds, and if your company decides that they want to keep that option open, you don't have to relearn. Okay, so now we're going to do a little bit of Pulumi one-on-one. I kind of brushed aside some of those things that we saw there, like these strange types, right? What is a Pulumi.int and a Pulumi.string? Yeah, this TCP port 80. What's going on here, right? So fundamentally, cloud deployments are asynchronous, right? Some values are static, and we know them at authorship time, right? For web servers, we always want to expose that port 80, but others only resolve at runtime. So what is that public IP of our EC2 instance? Well, you don't really know until AWS creates it for you and returns it back. So we have this notion of inputs and outputs in Pulumi. So we're gonna just get into some very light kind of type theory. If you haven't seen this before, it's okay. We'll explain it every step of the way. So let's just think T is symbolically as like some type. So T is maybe it's a string, or maybe T is an int, or maybe it's an array of strings, or perhaps it's a struct, right? So T is just some raw concrete value. An output of T, something that maybe is produced by a cloud resource, right? So an output of T is an asynchronous object that resolves with a value of type T. So for us, we could think of our public DNS name as an output of type string. It doesn't exist when we write our program, but we know that when we run it, eventually it's going to resolve with a string. So it's kind of like a promise for any of those of you who are familiar with JavaScript and the web. And when we create that EC2 instance, it's not just that public DNS, it's every member of the results object is an output. So it has to be async. We really can't know these values ahead of time. And we want to be able to propagate these values from our EC2 instance or from our security group into our EC2 instance. So we have to model these outputs asynchronously. And now an input of type T is either an output of T, which is that future that we were talking about. So an input of T either promises to eventually give you a T or currently has a T. So it either says, I will give you back an int eventually, or I have an int right now. It's either one. And this allows us to support both promptly available arguments, like our port is always 80, or something that's maybe computed, like we're going to create this resource group, and that resource group is going to have an ID, and we're going to need to wait for that ID to be created for us to give to our EC2 instance, right? Allows us sort of this coordination. So every input when creating a cloud resource is going to be an input of T, and every output is an output of T. Yeah, it's a little redundant. So why all of these custom types, right? We have Pulumi string, Pulumi int. What does this have to do with prompt and available values, right? Well, Pulumi uses generics over union types to represent inputs in other languages. So input of T is the union of T and output T, right? Go, as we all know, lacks generics for now, so we must define our own custom types. So for Pulumi, a combination of these custom types using interface and reflection under the hood allow us to represent this type system while still offering a strongly typed API on the consumer-facing side of things. Questions there? Okay, we'll go ahead and move on. So, we have these asynchronous values, these outputs, right? And sometimes we need to manipulate them. Very common to take a protocol, a host name, a port that's returned, want to construct a fully qualified URL. Well, you can't just, printf a future, right? Like that's a complex struct, right? You can't just printf that thing, and you may not have that those values available when this statement of code executes at runtime, right? These are futures; they resolve when they resolve. May also want to, for instance, set a value of a struct based off of something that comes back from an output. Yeah, what if these values are async? Well, that's why Pulumi has something called apply. And apply allows us to specify a callback function that manipulates the underlying value when it becomes available and produces a new output. So we can call apply on our port and then return a URL that contains that port after the fact. Here's a great example here. So we've created a VPC, and that VPC has an output, which is a DNS name. So this DNS name is an output of type string, string output in Pulumi Go terms, and we're going to call apply string on this. And this callback function will be called with that DNS name when it becomes available. And we're just going to append a HTTPS on the front of it to return a fully qualified URL. And so now URL is not actually going to be a string, it's an output of type string, right? Because this apply string is asynchronous and returns another asynchronous value. So it's kind of like promises and chaining .then together if you've ever done anything like that. So sometimes we need to coordinate multiple outputs. Like maybe you have a database and a server that are getting created and you want to create a connection string. So all is how we coordinate multiple asynchronous output types, creating a new output, right? We can combine this with apply to manipulate asynchronous values together, right? So here we have a SQL server that's been created, and we basically call pulumi.all to await the server and the database, and we say, hey, when both of these are ready, execute this callback and return me this connection string. And once again, connection string is not a string. Connection string is an output of type string, right? So that means that connection string is an asynchronous value that promises to eventually resolve with a formatted string once SQL Server and database have resolved. So Pulumi, trying to, us personally trying to create some more idiomatic and useful Go have created a utility function. So if you're doing this just in the basic case where you're awaiting a couple of strings, this is very common. We have a pulumi.sprintf, which hides all of this from you. But now you know what's going on under the hood. Questions here. What is sprintf? Sprintf is just like printf. So sprintf in Go is the function that is used to template strings. So let's go back and look at this. So we can look at a real instance of sprintf. So this slide here says fmt.sprintf. And every the first argument of sprintf is going to be the format string, and so in this case, all of the other arguments of sprintf are the parameters that we want to substitute within that format string. So in this instance, this is gonna create a if protocol was HTTPS and host name was pulumi.com and port name was 80, this would return https://pulumi.com:80. So that's sprintf. Let's see. And so pulumi.sprintf is just the asynchronous version of that to operate over outputs. Let's see. How can I wait for the output to be ready for further usage? So the way that you handle that is you never access the raw value within an output directly when writing a Pulumi program. You always use pulumi.all and pulumi.apply to basically schedule these. So Pulumi basically builds a big dependency graph, right? Like every time you write a pulumi.all, every time you write a pulumi.apply, Pulumi creates edges inside of this graph basically, and then eventually does a topological sort over top of that graph, and then just looks at what is the first node that I can pull off and start executing and resolves those dependencies, and continues to do that and does it in parallel wherever possible. So more or less you have to use all and apply because the cloud just by nature is asynchronous. Is the Pulumi SDK feature set identical between Go, Node, .NET, and Python? Which language implementation gets developed first? Okay, so the Pulumi SDK for Go is been in preview for a little while now, and we've been working really hard over the last quarter, and we are actually GAing and launching 2.0 of the Pulumi platform, which includes GA of all of our languages. So all of our languages are officially supported now. Okay, so moving on here, we're going to talk a little bit about architecture as code. We hear a lot about infrastructure as code, but not so much about creating reusable components and architecture. It's certainly possible to do in YAML and DSLs, but this is our bread and butter when working with programming languages, right? So we want to encapsulate our design. We want to compose our infrastructure into useful units. We want to extract these into functions, publish them into libraries, unit test them, and be able to share these best practices across our teams. Sometimes you have, maybe a junior engineer on your team who you want to be able to allow them to create a web server and maybe put some HTML inside of it, but you don't want them to necessarily change the network configuration. Like maybe they don't have that expertise, or maybe you are a security engineer and you've set up these best practices and you just want to hide the level of or control the level of abstraction that's exposed. This is something that we do all the time in software design, but something that's not so common in infrastructure. So let's take a look at that web server example that we just had. And here we've encapsulated this into this create infrastructure function. And create infrastructure is going to return this infrastructure object, which contains a security group and a server. And here we've actually said, hey, we're very happy with the functionality of our web server. We don't want to provide any configuration to our customers at all. So we're just going to control the entire thing. So some things to note here: instead of using a user data string to start up that web server, we've actually baked an AMI ahead of time so that that web server will start up automatically. And here, now our code executing inside of our Pulumi.run, looks a whole lot simpler, right? We just call this create infrastructure function that returns this infra object that has our security group and our server inside of there. We can still export those values as we did in our previous program. And these improvements are shared, right? So we bake that web server, like I said, into an AMI instead of having to use user data. There's no worry about let's see, if I'm an engineer and I'm just getting started and I'm like, hey, I instead of saying hello world, I want to say hello world, hello mom. Uh-oh, I just made a big mistake in my shell script, right? So we have the ability to write abstractions that we could parameterize this HTML, this message that gets echoed into this index file, and build that AMI. We have the ability to do that and control that with these encapsulations. So testing. Let's get into testing. All right, since we're in the Go ecosystem, can we use all of our favorite tools that we use for, Go test, right? The built-in one. What about the tools we use for mocking or code coverage tools? And the answer is, of course, yes. Yes, we can use all these things. We want to use all these things. These are the things that we're using every day. So let's write a unit test against our create infrastructure function. We want to verify a couple of things, right? So we're building some operational tooling around tagging. We want to make sure that we're able to query every EC2 instance with the web server tag on it. So we want to verify that that name tag is on there. We want to make sure that no one is specifying user data, right? Because we have already baked in with the AMI that web server, and we don't want any conflicts there. And we also want to validate SSH is disabled. We don't want any of our public-facing web servers to have SSH on them. We want to make sure that none of our user data is at risk. Okay, so this is another opportunity to go ahead and grab your computer. And once again, we're still inside of this Pulumi examples repo. So if you're inside of the Pulumi examples repo, all you need to do is cd into testing-unit-go and run go test. So let's go ahead and do that. Great. And while that gets started, let's go ahead and look at some of this code. So we have this test function here, test infrastructure, that instead of running inside of Pulumi.run, we run it inside of Pulumi.run error, which allows us to specify a set of mocks. I'm not going to go through these mocks. They're not particularly interesting. It's just a couple of lines of boilerplate, but they're in there in the examples repo if you'd like to look. So we run those mocks. We create a weight group that corresponds with the number of assertions and the number of tests that we'd like to run here. And then we do those assertions, run that weight, because these assertions are going to happen asynchronously inside of our all and apply calls. And then we assert that there's no error at the end. Let's just go back here. So we see go test passed in half a second. Excellent. So what do these tests actually look like? So we want to be able to check, do we have a tag with the name field, right? And we want to check for each server. So for now, we're only creating a single server. But we want to make sure that when we report an error on that server, we know which server in case we add more in the future, right? In case we're doing this inside of a loop. Okay, so we have pass in the URN of that server and pass in those tags, wait for all those to be promptly available or eventually available, and then execute this apply T where we take that first value, which is going to be the URN, the second value, that map of tags, and we're going to check to make sure that map contains the tag name. We're going to call done on that wait group. Okay, next, we're going to text and make sure that all of these user instances do not have user data specified. So similarly, passing in the URN and the user data and calling all to make sure that those values are promptly available or eventually available. Once they're eventually available, this apply T function will execute, and we will assert that the user data string is nil, right? If it's not nil, we're going to throw this error, illegal use of user data on server URN. Once again, calling done on that wait group. Finally, we're going to test and see if port 22 is exposed. So this one is a little bit more involved. So we're going to iterate through all of the ingresses and check for that wide open CIDR block there, right? And if we find that wide open CIDR block, we know we're open to the internet, right? And we're going to break out and we're going to check and see is the port that we just found a public CIDR block for 22? If so, if we're open to the internet, then we've got an illegal SSH port, and we're going to fail the test. This ensures that none of our tests none of our web servers are open to the internet. It's a nice thing to be able to verify locally. So, once again, this is unit testing. We aren't verifying the functionality of a particular cloud service, the behavior of your infrastructure. We don't have, this isn't extensive mocking, so we can't make an HTTP query. We're not mocking out all of the cloud services. But what we can verify is the control flow, the logic, the propagation of expected values through your code, right? The number of times that the create call to a given resource gets made, right? So the behavior of your code in isolation and not the cloud. And the great thing about this is it's blazing fast. You can do it locally without the CLI, without an internet connection. You have a tight feedback loop. Any questions? Okay, so first question, do you have a recommendation, just enough Go to be pertinent Pulumi, or is someone familiar with Java? Well, I would say that Pulumi supports Node.js, TypeScript, .NET, Python, and Go. So if any of those other languages are interesting to you, you can use Pulumi in those languages. This examples repo that is included in the links in the slides, which I'm going to share after the fact. The examples repo has multiple examples for all of those languages across multiple clouds. If you're a Java developer, .NET might be a little bit easier to get started with. I can definitely give you some recommendations after the fact, as I'm sure everyone else within the group has lots of recommendations on getting started with Go. I think it's a great language. So let's see. Leon, speaking from experience. Okay, moving on. So, we also, sometimes we do want that full confidence. We do want to take the time to spin up an ephemeral stack and execute end-to-end workflows, right? Making requests against our live infrastructure, verify like these integration of these different pieces of cloud services, this end-to-end request flow. And then we want to automatically clean up that environment. Whether or not the test succeeded, we don't want to leak resources. We don't want to keep paying for that, right? So Pulumi has a test harness, our integration test harness, that allows you to do just that. And in just a few lines of code, see, we configure here a directory which says this is where my Pulumi program exists, a config map, which is the list of values that are required to inject into the program for it to be able to run. You saw when I initially ran my program, I did Pulumi config set AWS region. This allows us to do that inside of code in this automated test harness. And then this extra runtime validation function is going to be run with the resulting stack. So that stack is going to be populated with stack outputs. So you will be able to access that website URI, append it to a, like turn it into a fully qualified URL, and assert that when we make an HTTP request against it, we get that hello Pulumi back. And then we just do an integration.program test, passing in the Go testing object and the Pulumi test configuration. This program is going to execute, spin up my web server stack, do the extra runtime validation, and then tear it down, reporting the results. And I don't have a demo for this in real time. It can take a couple of minutes to spin up cloud resources, execute these requests, and tear it down. These tests are very, very valuable, but they are a little bit more expensive in terms of time. They're not necessarily as great in that tight feedback loop. But this deploys real cloud resources and validates their behavior. So this can catch bugs in things like IAM and access control, making sure that your requests can flow end to end through the system, making sure that Lambda has the ability to pick up that file out of S3, make sure that propagation of secrets happens as you would expect. It also allows you to do some really interesting things, like this integration test option allows you to specify a directory, but it also allows you to specify an edit directory. So you could have a second version of your program, perhaps checked out to a different revision of the code, and then simulate an update. So you could spin up your resources on the initial Pulumi up, and then by specifying that editor, do a second Pulumi up on a new version of the code, simulating a deployment. This may allow you to measure uptime, make sure that you still have database availability, make sure that none of your resources get deleted. So this is a great way if you're making kind of a risky change and you're concerned, you want to game day it ahead of time. Pulumi makes it really easy for you to do that. You can also do things like verify health checks and alarm configuration. So like I said, this is much slower than unit tests. This is not always a great thing to have in your tight dev feedback loop, but before you go to make that pull request, you want to verify every corner case of your infrastructure that maybe you didn't touch when you were working on this feature. And that brings great confidence and enables CI/CD for your infra, which is something that's not always that common. It's more common than you would hope to have to babysit these builds and babysit these deployments. So we want to be able to hit that big green merge button and sit back, dust off our hands, and go work on something else. We don't want to have to babysit. So with that, anyone have questions about integration testing? Okay. Oh. So just taking a look here at the ecosystem. So Pulumi is tightly integrated with all the source code providers, all the identity providers that you would expect. We support a suite of languages for authorship, including TypeScript, Go, Node.js, Python, all of the .NET languages. And with those languages comes the tools that you're used to, the package managers you're used to, the editors you're used to, the CI/CD integrations, right? On top of that, we have support for all the cloud environments. AWS, Azure, GCP, Kubernetes on any cloud that you want, OpenStack, VMware, the list goes on. So just in summary today, we talked about how do we provision our applications. Treating our applications, our infrastructure apps as cattle, not pets, right? We spin these things up, we spin them down, we onboard a new teammate onto the team. You send them through the Pulumi getting started flow, and there you go. They're up and running and ready to deploy your application. That's it. There's no creating resources through the console, no complicated custom setup. We also talked about how do we take a cloud resource and turn it into a piece of architecture that we can, this abstraction that we can encapsulate, a best practice that we've defined within our team, and share it at that correct level of encapsulation, at that correct level of abstraction for that given consumer, right? Expose the things that you want to expose. Maybe allow them to specify the HTML that gets rendered inside of the web server, but don't allow them to configure the network configuration. Don't allow them to change that, right? Pulumi allows us to do that. And then finally, we talked about testing. So the unit and integration testing strategies that give us the confidence to move quickly and deploy often. So, I just want to say thank you. And thank you to Hatch IT for setting this all up. And thank you to all of you for coming here and talking about Go and talking about Pulumi tonight with me. Here's some more ways for you to learn about Pulumi if you want to join the community. So we have everything from Slack to GitHub, where all of our work is done out in the open. So you can go and see pull requests that I've been working on this week, or the rest of the team has been working on in preparation for our 2.0 release that's coming up in the next 2 weeks. We have video tutorials. You can always reach out to me directly on our community Slack. I'm there all the time. And we have more workshops coming up, a lot of them in languages other than Go, if there are those of you out there who might be interested in learning some other languages as well. So.
Awesome, thanks, Evan. And I want to make sure, I think there were a couple more questions in the chat, if you are able to address those. Looks like one that just came on was from Frank. It says Go is quite famous for single binary. Is this possible as well, or Pulumi? CLI is always needed.
Okay. So let me okay. Pulumi is famous for single binaries. Is this possible as well with Pulumi, or is the CLI always needed? So this isn't documented. This isn't something like, this is something that we've looked into and had customers ask about, but you can technically bind directly into the Pulumi engine without using the CLI. So that code's there, you can build it if you want. You can link into the engine and interact with it directly. It's not well documented, but for the time being, Pulumi does require that CLI binary as well as your program binary. The other thing about that is we've actually heard a lot of requests from the community for a runtime API. So exactly what you're talking about, single binary, but more so across all the languages. So this is something we've been investigating. If you're interested, hop on Pulumi Slack or send me a tweet, and I can link you to the issue, and you can chime in and learn a little bit more, maybe help shape the direction that goes.
Awesome. Any other questions?
I see here IBM or Spring Cloud on the list. I can link you after the fact to a full list of the cloud providers that we have. I think there's something like, Isaac can correct me if I'm wrong, but something like 30 or 40 different providers that we have at the moment. I'm not sure if IBM or Spring Cloud is on that list.
And Emmanuel had one earlier that you had wanted to table.
Right. So tools like Pulumi or Terraform are generally at the mercy of AWS API, which doesn't always support all the features you want to have under IAC. To get around that, Terraform lets you inject CloudFormation template and potentially resolve this. Is this something similar possible in Pulumi? So I've never had to do this with Pulumi. I have had to do this in CloudFormation in the past with I think you're sort of referring to like the pattern where you spin up a Lambda that does some custom resource creation or execution. Pulumi does have the notion of dynamic providers, which allow you to basically create your own custom CRUD interface. So there is that. I don't actually have a great answer for you. If you go and ask that on our community Slack, or if you tweet at me after the event, I'll be happy to get a more clear answer for you.
Awesome. Okay, very cool. So it looks like that is it. Yeah, I think we got them all. Great. Thanks for presentation. Oh, we got one more.
Is there a GUI for Pulumi? So one thing that Pulumi actually does have, which I didn't show, but if you go to pulumi.com, so I'll go ahead and sign in here. And we can actually see, if I go to my organization, my personal organization, you can see the projects sort by last update. So you can see all of my preparation in the last couple of days, all the stacks of my Go web server that I've been creating and deploying to, and you can see the one just 35 minutes ago. So there is a GUI for Pulumi that allows you to work easier across teams, manage deployments, manage resource updates, and yeah, this is a part of the SaaS that's free for individuals and that companies and teams have access to. Is that what you mean by GUI? And I'll type that in there. It's app.pulumi.com. More like drag and drop to generate scripts. That is not something that we have in the moment, but if that's something that you'd be interested in, please feel free to open up an issue on Pulumi GitHub. It's linked right here, github.com, Pulumi. Open up an issue for that and be interested to hear more.